Today we're starting 3.1, graphing relationships. The word constant means staying the same. What word means rises? Increasing. What word means drops? Decreasing. And what word means slows down? Decreasing. Please know that these two both mean the same exact word. Some words have multiple meanings. What we're going to be doing in this section is we're going to match simple graphs with situations. Two different types of graphs: continuous graphs and discrete graphs. I'll give you a second to get this page copied. Each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no leaves left on the tree. We're going to choose the graph that best represents the situation. There are three graphs here: graph A, B, and C. We need to figure out which one is the best. Now, from left to right represents the time. Bottom means there are no leaves. Top means there's a lot of leaves. So we need to look for the key words. The first one, never horizontal. Horizontal means you stay leaves on the tree. Leaves are falling off the tree, right? So which one never has a horizontal piece? B. B never has a horizontal piece. Which one is going downward? Because we are losing leaves. So we're going to look. Which one shows that we're losing leaves? All of them. All of them are losing leaves. Which ones reach zero? Which ones have no leaves? All of them have no leaves. Now, looking at this, you can look at it this way. This one here doesn't make sense. Does anyone know why? It gains leaves. How could a tree gain leaves? Okay, it's growing leaves, then it stays the same, then they fall off. All right? This one, they fall off. This one, they fall off. Then they stay for a while. Then they fall off some more. The best one was B. They fall off. They fall off faster, and then they all fall off. This is what we're doing in the graphs. We're trying to figure out which one's the best representation. I want you to look at this graph and figure out which one's the best representation for the air temperature steadily increased for several hours, then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. So the air temperature increased steadily. So it increases steadily. Increases steadily. Which one increases steadily and then drops sharply? I'm sorry, steadily, then constant, and then at the end of the day, increase slightly, then sharply. C. Because if you look, this one started off constant. Constant is a flat line. It's constant speed. Constant. This one went up, then constant, then it increased slightly, then it dropped sharply. This one is graph C. Good. As seen in our first example, some graphs are connected lines. If they're connected lines or curves, those are called continuous graphs because it's just a set of continuous dots that are connected. Some are only points, distinct points. Those are called distinct graphs. The graph the graph on the theme park attendance is an example of a discrete graph. It consists of distinct points because my graph went over top. Year is distinct and people are counted in whole numbers only. The values in between whole numbers are not included since they have no meaning for the situation. So write down the necessary information from this page. Notice that for each one. If you buy a ticket to the football game tonight, say 1,000 people go. Can you have 1,000.5 people go? Why? You can't have half a ticket. You can't have half a person. You can only sell whole tickets. So you can't connect these. They're distinct points. That's why you can't have connected lines. Because here, if we're talking about time, 1 minute, 2 minutes, 3 minutes, what's in between each minute? Seconds. Something happens in between those minutes, right? But does thing happen in between each ticket? No, it doesn't make sense. That's the difference between a continuous and a discrete graph. A truck driver enters a street and drives at a constant speed, stops at a light, and then continues. As time passes during the trip, moving from left to right along the x-axis, the truck's speed, the y-axis, it does the following. It increases, remains constant, it decreases, then it stops. Yeah. When you enter the street, what happens when you drive? You start driving, right? So you enter the street, you start driving, then you remain constant speed, then you have to slow down and you stop, then you have to speed up, and then you remain a constant speed. This is a continuous function. Yes?
So if you the street, okay, so if you walking, right?
Right. If you're walking, that's a continuous function. If we can do something, that's continuous. If we're talking about something over time, it's a continuous function. I should have put the screen up. For this situation, it's books. I have a book. There's books are sold between 5 and 8 books each day for 7 days. When you graph it, it looks like this. It varies. You notice that you can't sell the books in between each day. It varies. Since you can only sell a whole number of books, it is a discrete graph. Do you understand the difference between continuous and discrete? All right. On this page, instead of going over example after example after example, here's it takes it and breaks it down into different pieces. If you see a graph that looks like this, it means something is increased sharply, dramatically, quickly, rapidly. Those are your key words. Decrease, steadily, gradually, slowly. You see these little bumps that look something similar to this. They don't have to be all this sort of bumps. But the bumps look like this. It could be any of these words. Flat line means remain constant, stayed the same. Just a slight slant means gradually or slowly, steadily. A sharp slant, sharply, dramatically, quickly, rapidly. And these bumps is an uneven pace. So what I want you right now is I want you to give two phrases that could describe this. I want you to try to draw a little sketch here that could show me the speed of a car that decreased dramatically and then remained constant, and then match up 3, 4, and 5. What's one phrase we could say for this one? Increase steadily. What's another one? Quickly increased. Increase slowly would be better. Increase gradually. This one, it's not like. It's more like this one right here. A couple of you thought it was this one. It's more like this one right here. Someone want to come up and draw this one? Go ahead. It decreases and then it remains constant. You have the eraser in your hand. That's fine. That was fine. Good. I'm just going to move it over just a bit so everyone can see it. Goes down dramatically and then remains constant. Perfect. Now the baby lost a little weight, then gained weight slowly. The baby gained weight at a rapid pace, and the baby gained weight at an uneven pace, then maintained weight at a constant weight, or maintained a constant weight. With the calculator. All right. This right here means uneven. So this, I'm looking for uneven at first is C. And that would be C. This one here is, what does this mean? Lost. And lost is A, which automatically means this one has to be B, but this means increased, gained, B. Any questions on this? It's not that bad.